In this video, we're going to introduce graphs for qualitative data. So you might ask yourself, well, we have all the technology and tools we need to get information from a data set. So with all the tools and techniques we have, why should we bother getting a visualization? It almost seems like it's unnecessary. And although it might have been something that we really would have questioned before we had a lot of technology to assist us in visualizing our data. But think of it this way. Let's say you were in the market to buy a car, and I told you that, well, I can tell you all the data you want regarding a car. I can tell you the make, the model, the mileage, color of it, maintenance, repair history, etc., how many previous owners it had, everything like that. However, ultimately, before you buy the car, you're going to want to know at least what it looks like, whether it's in person or a picture of it. So the same principle can be applied to data sets. We want to get an idea of what the data set looks like visually, even though we have all this technology available to us to get a lot of the information we're going to need throughout the course. So in this video, we're going to take a look at creating and interpreting bar graphs. So a bar graph is a visual display of data in which we use bars where one dimension represents each category and the other dimension is either going to represent a frequency for that category, a count of that category, or a relative frequency, a percentage of the total of each category. So here we have a bar chart representing various hours worked each day during the week. So as we can see, the height of the bar represents the total number of hours worked for that day. So we have 5 hours worked on Monday, 8 hours worked on Tuesday, etc. And it just gives us a nice quick visualization to see that, well, Friday is the tallest bar. So we worked a total of 9 hours Friday. And then from there we can look at comparing total amount of work hours that week or whatever it is we want to do. So we can also cluster our bar graphs together. So let's say week 1 we worked for 5 hours on Monday and then 8 hours on Tuesday. So the red bars represent the week 1 information. And then since we're using the same days of the week for our work schedule, week 2 we're going to use the blue bar information. So on Monday, we had 7 hours the second week on Monday, 4 hours worked the second week on Tuesday, etc. And what this does is it gives us a quick visualization of how many more hours we worked on the second Wednesday than the first Wednesday, or how many more hours we worked on the first Thursday compared to the second Thursday. So we can also create what are known as stacked bar graphs, where we take week 1's total plus week 2's total for each of the days and then stack the bar graphs on top of one another. So in our previous one, for instance, we had 5 hours on the first Monday and 7 hours on the second Monday, make a total of 12 hours for our Monday. And then same thing with Tuesday, Wednesday, Thursday, and Friday, where again, we just stack the second week right on top of the first. So the second one picks up on the bar graph where the first bar leaves off. In this case, where the red bars for first week leave off. We can also make our bar graphs horizontal. So it's pretty much just like it was in the beginning. But now our vertical axis is going to be the day of the week, and our horizontal axis is going to be the hours worked for each of those days. And we can also create bar graphs, again, to show relative frequency. So this is a percentage of the total. So for our first week, we had Monday was about 14% of the total hours worked that week. Tuesday was about 22, maybe 23% of the total hours worked that week. So to create a bar graph, it helps to create a frequency chart of the information. So a frequency chart is going to display the count of each observation. So for instance, we had 5 hours for Monday for that first week. And then we can also use that to create a relative frequency chart as well, which looks at percentage of the total. So for our first one, we had Monday, we had 5 hours worked. Tuesday, we had 8 hours worked. So here's our frequency chart for the days of the week and the hours worked. Here is our relative frequency. So on Monday, that was about 14.29% of the total amount of hours worked that week. Tuesday was about 22.86% of the total hours worked that week. So we had 13, 20, 35 total hours. So. All right, so example 1. 1 week, a questionnaire was given to hotel guests to asking them to rate their satisfaction with their experience at the hotel. So the ratings range from 1, which is not very satisfied at all, to 5, which is very satisfied. So we're going to construct a bar graph for the raw data below. So first thing we want to do is we want to get a count of how many 1s, 2s, 3s, 4s, and 5s we have in this data set. So we have 30 data values here. So we want to get a count on how many times each one of these values occurs. So we had a 1 occur 6 times, a 2 occur 5 times, 3 occurred 7 times, 4 occurred 5 times, and 5 occurred 7 times. So here is our frequency distribution for our hotel ratings. Now from there, each one of those frequencies is going to be the height of the bar for that particular score. So again, 1, we had a frequency of 6, so the height of the bar for 1 is 6. For 2, we had 5 of them, so the height of the bar for 2 is 5. And then we see for 3, a rating of 4 and a rating of 5 have 7, 5, and 7 respectively. All right, example 2, construct a relative frequency bar graph. So our relative frequency, we have a total of 30 hours, or a total of 30, not hours, I'm sorry, a total of 30 results that we got back. So we got 6 1s, which 6 out of 30 is 1/5, or 20%. We got 5 2s, and 5 out of 30 is 1/6, or about 16 and 2/3%. We got 7 3s, so that's 7 out of 30 for that. And then the same thing with 4s and 5s, 1/6 and 7/30 as their relative frequency. So we can also express relative frequency as a fraction, a decimal, or a percentage. So here's our relative frequency bar chart for our hotel ratings. All right, example 3, seeing the results of the questionnaires, the hotel made some changes in the following month, asked 40 new guests to rate their experience. The results, along with the previous results, are listed. So we had our 30 from the first sample and now our 40 from sample 2. Construct a stacked bar graph of these results. So for a stacked bar graph, we're going to have our 5 bars, 1, 2, 3, 4, 5 for each rating. And then the heights are going to be just the totals across the rows. So 6 and 4, we're going to have a height of 10 for a rating of 1. We're going to have a height of 8 for a rating of 2. We're going to have a height of 19 for a rating of 3, etc. So we can see where, and the legend here kind of cuts into it a little bit, so I apologize for that. Where we can take the second one, the second sample, the next group, and stack those on top of our first group. So this one keeps a nice running total of all the 1s, a nice running total of all the 2s, the 3s, the 4s, and the 5s. All right, example 4, given the bar graph below, find the percent of people who travel in the summer. So here, this one is nice because it actually lists the heights of the bars above each one. So really nice when we're given that information. So we want to know what percentage of the total here are the ones that travel in the summer. So we have to add up the heights of these 4 bars, and when we do that, we get 1,096. And out of the 1,096, 345 of them travel in the summer. And if we convert 345 out of 1,096 to a percentage, just divide 345 by 1,096 and then move the decimal 2 places to the right, we get about 31.5% or 31.48% of the people travel in the summer. Now, we can also, for our bar charts, use what's known as a Pareto chart. And a Pareto chart is nothing more than a bar graph or a bar chart in which the data is listed in descending order of frequency or relative frequency. So we start with our our highest frequency value, which in this case is summer, and then we go in order from highest all the way down to lowest, which in this case is going to go from summer to fall. So If we create and organize from highest to lowest, we see that summer followed by spring, followed by winter, followed by fall. So Pareto charts are nice because they give you a real quick instant glance as far as which one has the highest frequency or highest relative frequency, because it's always going to be the one that's the very first one farthest to the left. All right, that about does it for this video. Thanks for watching. I'll see you next time.